Every graph needs the same set of stuff, so I'll show you my 1A. Here's what I did for 1A. You can take a look at what you got. I had a discussion with a few of you guys about the lines of best fit. We can talk about those today as well if you want. Every graph needs a title. There's my title. It's the two things you're graphing. I've got my axis labeled reaction distance in meters. I've got my other axis labeled velocity in meters per second. I picked a scale that was big enough to encompass my whole graph. And then this is the line of best fit that I drew. That was, I did it again. That was one of these. That's from a couple years ago. This is the one that I did on Thursday while I was helping some people out. So I picked a slightly smaller scale, used about half my graph this time. My line of best fit was slightly different. And then so my equation's going to look slightly different. I didn't actually put the equation on this graph. So, and you can put them right on the graph. Like I think it was these guys at this table here were asking, where do I put the answers to the questions? Everything can go right on the graph. So then the equation for, oh no, it's right here. The reaction distance is equal to 0.73, the slope, times the original speed, I just called it OS, plus 0.25, and that's where my y-intercept was. Unless it actually goes through 0, 0, don't assume it. I mean, 0, 0 makes sense. If you have no original speed, your reaction time is going to be 0. But that doesn't, it's not what the line shows. So even though your line might go against what you believe common sense to be, that's fine. This just becomes plus or minus, well, in this case, plus 0.25. It's error. And then my other one actually went through 0, 0. So I was able to just have 0.75 times velocity. Same guy, same data, two lines of best fit, two different slopes. That's fine. As long as you're in the neighborhood of 0.7 to 0.75, even 0.68 to 0.78, somewhere in there, you've got a handle on these. Mrs. Pearson, how's it going? Good. I don't actually teach grade 9s. Did you see my email? Okay, comments, questions, concerns. 1A, there it is. Okay, so then my 1B looked like this. I had you guys graph 1B and describe the differences in the two graphs. This one, if you draw a line of best fit, I mean, it's kind of hard to make this data look linear. It does actually kind of look curved. So I'm going to show you guys the tool I said I was going to show you on Monday, and then I was away for 2 days. I'm going to show you guys how to graph curved lines of best fit today. So this is what that graph would look like. It doesn't ask for the equation for this one. It just says to graph and then describe the differences. I would say that this one looks curved as opposed to the other one, which looked a lot more linear. But that's, so I demonstrated two lines and what they would look like there. Comments, questions, concerns on this guy? Okay, cool. Question 2 was this guy here. The total distance of a lab cart travels during specific lengths of time is given below. This is what my graph looked like for this one. So I've got my title, distance versus time. These scales are, again, based on the data that I've got. So don't, I was having a conversation, I can't remember who the conversation was with. Don't use, like the data should not be your scale, but the data should determine what kind of scale you should have. And so like these ones, the distance 0.32, 0.60, 0.95, 1.18, 1.45. What I mean by using your data as your scale, I had someone literally put these numbers going up the side. That's never how you want to graph. This, though, should give you an idea for the scale. We've got a minimum of 0 because the thing presumably starts at 0. It's got, we have to exceed 1.45. So what I chose to do to use as much of the graph paper as possible was I decided to call every 2 lines 0.1. So then it goes 0.1 and then 2 lines 0.2, 0.3, 0.4, 0.5. It took me all the way up to 2 meters here. I was having another discussion with another student, and they said, well, but you only need to stop at 1.5 because the data only goes to 1.45, so why could you not just stop there? You're right, I could stop there. But when you're graphing these things and looking for equations for them, You might not actually get good points for your lines within the data spread that you've got. So like if I'd only graphed 0 to 1.5, I might not actually find, especially if I'm doing these by hand, a good spot to actually run the graph through the grid. I need 2 of them to create the slope. And so I extended it all the way out to 2. I blew my line all the way out to 2. And in fact, I used 1.55 as one of my points for the slope. So then I found the slope of this thing, what it was asking me to do. There's my plot. Well, the thing looks linear. I determined the slope to be 0.3. I determined the equation of the graph to look like this. So we always, if it looks like a straight line, you're always starting with y equals mx plus b. But then you're replacing y and x with whatever your variables are on the y and x axis. So distance is going to look, or distance is in the y, time is in the x. So my equation is going to become distance equals 0.3, my slope, times time, and then plus my b value. My b value happened to be 0, because that certainly looks like it goes through 0, 0 to me, but yours might not be. If your line of best fit looked anything different than mine, you'd have a value that it goes through. And then what would you predict the time to travel 2 meters? What would the distance traveled in 18 seconds be? I'm just using the equation. You can either use the equation or just read it off the graph. If I'm reading it off the graph, I'm going to go up to 2 meters. I'm going to go over. I'm going to go down. I would predict that to be 6 point, what is that? 2, 4, 6. That's 8. 6.7. If you actually go and calculated it, I found it to be, using my equation, found it to be 6.67. So if you were looking at the graph, you can say, oh, that's basically 6.7 seconds. Okay. When you calculate it to be 6.67, that's pretty good to me. What's 3 centimeters? That's really what that means. That second decimal place there is in centimeters. And then likewise for 18 seconds, that's way beyond the graph, so I just use the equation to calculate. 5.5 meters, effectively. 5.4. So obviously your values are going to be different here if your line of best fit slope is different, but you should have, it's the procedure that I care about, especially when you're doing lines of best fit. I'm less concerned with that the values line up exactly like mine do. I mean, for the first time, I actually had a student pull exactly the same values I did. Ray Reet, our first graphs were identical, which is weird, but cool. So that was question 2. Questions, comments, concerns. Well, it's Wednesday morning, first period. We're all a little tired. I've been cooped up inside for a week, and so I got a little more energy than you guys do, apparently. Okay, 3. This is where I told you guys to not connect the dots. I hope you all have something to work with for 3, because I'm going to show you what this thing looks like. The intensity of light is determined in lumens, and here's the data. And we want to plot distance versus, it shouldn't have been time. I fixed it for you guys, intensity. Because it's intensity. The distance is the dependent variable. Intensity is the independent variable, because you change the distance you are from the light source, and then the intensity of the light changes in response. So the further you are away, the less intense it gets. So you guys should have had data. You know what? I'm going to rank this one out real quick here. Okay, I'll pull this thing over. I hope you all have something to work with for this guy. That. Okay, so here's my graph. Let's make this thing quick. There's 10 of these box sections up the side here. So going up to 100, a really easy scale to do is just to call each one of these major blocks 10. So I'm going to go 10, 20, 30, 40, there's 50, 60, 70, 80, 90, there's 100 up at the top there. And then, oh yeah, 10, 20, 30, 40, 50. Okay, cool. If you have to use at least half, I'm just going to call that block 10, 20, 30, 40, 50, and we're over halfway. That's a totally acceptable set of scales. Now my graph's going to look like this. I have a point at 110. That's that guy there. I've got a point at 25 and 20. That's going to be that guy right there. I have a point at 11.1 and 30. So that's going to be 10. That's going to be 12. So that's going to be 11. I have a point at 6.3 and 40. So that's 2, 4, 6 and just a little bit. And then at 50, it's 50 and 4. So that's that 0.24 is right there. And the reason I didn't want you to connect those dots is I hope that your data looks like mine in that you can see this is obviously not linear. There is no way you're drawing a ruler-based line of best fit for this. And so there are tools that we have to compensate for this. We don't have a full class set, so you're going to have to share, but I want you to practice with these guys today. This, and this are the three different ones that we have. This one's called a French curve. I don't know why the French get credit, but they do. French curve. Slightly different French curve. Slightly different French curve. And these are designed because the natural world is based on so many different actual mathematical equations, like whether we discovered them or whether we invented them, the equations are there in nature. And we know that. And so every single curve on this French curve is based on a different mathematical function. We can get sort of the idea of, we can draw by hand different styles of graph. Every single one of these curves, and for different sizes too. So you guys need, for this one, you guys need these big ones. I have this thing. See how many I can get. You guys 2, you guys 3, you guys 4. No, I have 5. I can't count. You guys get 1. You guys get 2. You guys get 1. Oh, what did I give you? 3. 1. And so here's how you use this thing. And I want you all to have a chance to play with them. If you take a look at what we've got, you want, the easiest way to use one of these French curves is on as flat a surface as humanly possible. So if you've got coils on the side of your book, it can make your life a little bit more interesting. But basically, it's the same thing we do with a ruler. We want to take this thing, and obviously that's kind of works, kind of doesn't. You want to slide this French curve kind of along your data till it approximates everything you've got. See, something like this wouldn't quite work. As I maneuver this thing around, you'll get it to a point where you can kind of see it does a decent job of approximating, if not all, then the vast majority of your data. So like I got something looks like that might actually be a pretty decent curve. Now you can see here it doesn't hit that bottom one, but nothing's going to be perfect. Anything's better than doing it freehand. So I would just take this point, where's a pencil? And I would then draw and then I'll slide this guy down here and approximate the rest of this bottom data. Ignore the top data. I want to try and approximate these 3. And I'll get a curve that looks like that. Again, anything's better than drawing freehand. So I want you all to try with the data that hopefully you've got data in front of you. You guys have 2, 4, 6, and you guys play with the French curve. You guys have There's a second one for you. Well, I mean, quickly. You saw how quickly I cranked it up. Crank it out. If you didn't do it, and I assigned it a week ago, come on. Yes, Kai.
How can you put your distance on the y-axis?
No, I put intensity. Intensity goes up to 100. Distance goes up to 50.
Oh wait, so I thought we just liked the distance on the y-axis.
No, it's an independent variable versus a dependent variable. Which one are you changing and which one responds? So because intensity is changing with the distance, not the other way around. This is distance down here, and this is intensity up here. You don't choose your intensity, you choose how far away you are, and then the intensity responds. So play with your French curve. I want all of you to have a chance to. If you don't have your data done, get it done. I assigned this a week ago, and you had 2 work blocks. None of you should not have at least something here. How come the French curves are sitting there? Use them. You did them all? All of you used the French curve already? Okay, cool. So then now you've got a curve, we can actually use this thing, because the question says, what would you predict the light to be at the intensity of 25 meters? You can just, because we have no equation for this. If we use the computer, we could model the equation, and that's what I want to show you guys today. 25 meters is going to be in the middle here. 25 is going to go up. It's right there, and then we're going to go over from there. 10, 20, or 10, 12, 14, 16. That looks an awful lot like 17. And then the second part is, what would the distance, or what would the distance, what would be the distance where the light intensity is 50 lumens? So you go up to 50 lumens, and you go down. Whatever that value is, 10, 12, so that's going to be 14, so that looks an awful lot like 13 to me. And now you've got a meaningful interpretation of curved data using kind of a cool little tool. And you guys are going to do a lab for me in the next unit that you absolutely are going to have to do this. You're not going to be doing things by hand. You're going to go take some data. It's going to result in a curved line. You're going to need to use the French curve to create that line, and then you're going to take slopes at different points along that curved line. Do I have any calculus students in here? You're in calculus right now?
Oh, you know, sorry.
Like actual calculus? No? Okay. Then that exercise is going to make a lot of sense to you guys when you actually get to calculus. You look back, you're like, that's what we were doing, but not yet. So this is a tool I want you familiar with. So that was question 3. Question 4 is going to be similar, because if you graph question 4, where is my question 4? So here's my question 4. Okay, so question 4, I don't even know which booklet I'm in here. This is you guys. Question 4 looks like this. A student performed an experiment to study the relationship between the period T of a simple pendulum and the length L of the pendulum, and he obtained this data. So the period and the length. You guys needed to choose an appropriate scale and plot the graph. Don't connect. The reason I didn't want you to connect is because you're going to get something that looks like this. Something that could have sort of kind of looked straight line-ish, but is actually way better approximated with a curve. So I'm hoping you have plotted some of those points. I want you to use your French curve now to go ahead and draw the curve for this data. The data from 4A should result in a curved graph. And the curve should look like this. Some of them hearing whispers of it looking linear. It does. There are parts of it that look linear, but if you choose to draw a straight line of best fit, your data is actually way over, kind of all over the place. And the reason I didn't want you to graph, so I put a note on mine that says "Do not connect," and I showed it to all of you. The reason was because I do want to show you this data is actually way better approximated with a curved line. And how we know that is actually through, so there's a bunch of different mathematical techniques that we use to try and figure out what the relationship actually is. And so it seems like it's kind of cooked, and that's because it is, because I know what the relationship is. It says it seems kind of random, but calculate the square root of the length for each data values of t. And so the square root of the length, so the length is 100, the square root's 10, 81 is 9, 64 is 8, 7, 5, and 4. And so then if instead of graphing the period versus the length, we graph the period versus the square root of the length, you're going to get data that looks like this. And if you look at the data here, this is way better approximated by a linear graph than the previous one. So this is what the graph of period versus the square root of the length should have looked like. And because of that, because taking the square root of all those length values and then plotting them, because that actually forces this data into a straight line, it's going to give us a relationship between period and length. And it looks like this. So period I graphed up here on the y-axis. The square root of the length I graphed down here on the x-axis. And so once I've got my data, it's going to look like a straight line. I found my slope to be 0.2 effectively. And so now we can replace all the things in y equals mx plus b with their respective corresponding bits. So y is period. So then the period is going to equal my slope, 0.2, times my x variable. Well, x variable is the square root of the length. And on my blue line, which I drew 3 lines of best fit, my blue line actually does go through 0, 0, which your common sense kind of says should happen. If there's no length, there's going to be no pendulum, there's going to be no period. So then period is going to be 0.2 times the square root of the length. And so what this tells us is this graph that we graphed back here is actually an exponential graph. For those of you who have taken, well, this is Physics 11. I don't think you do that in Pre-Calc 11. Oh, whoops, wrong one. I don't know if you graph exponential functions in 11, if that's a 12 thing. So then the relationship would be this. Period is 0.2 times the length. And then in 4F, 4B and 4F, it says, in B it says, according to your graph, what would the period be of a pendulum that's 70 centimeters? So we can go back and we take a look here and we say, okay, well, 70 centimeters is here. I can go up to my curve and I can go over and say that's 1.65-ish. I can do the same thing over here and I can say, okay, well, if I take a look at my new equation and I'm going to say, okay, well, if I want the period, according to your equation, what would the period of a pendulum 70 centimeters long be? I take my length, 70 centimeters, I plug it in there. So the square root of 70 times 0.2 is 1.67. Using my first graph, I got 1.65. Using my linearized graph, I got 1.67. I don't know, 0.02 seconds, like that length of time is effectively meaningless. It's such a short window of time, it's effectively uninterpretable. It's not noticeable. It's actually quicker than my reaction time, if I remember back to when I had you guys playing with stopwatches last week. So that's pretty good. this is what I wanted you guys to be able to play and interpret. Questions, comments, concerns on this stuff? Okay. Hearing nothing. Okay, it is 8:50. Sweet. This is where, if you have a computer, I want you to get it out. If you don't have a computer, I want you to come with me to the lab, and we're going to grab you guys a computer from the science cart. If you have a computer, get it out. If you don't have a computer, come with me. Come grab one from the lab.
I don't know what he's talking. I don't know where he went. I fell off for like 5 seconds in my thoughts. I look out and go, what's the order of these equations? I don't know what's going on. So sick, guys, over, bro. It's over. I don't know what he was. I don't know what he was doing. He had curved graph and linear graph. I thought it was the same graph. Well, no, on that he did, instead of doing the centimeters here, he square rooted all of them and then decided to go with the first one and this one and create a linear graph. So if you were to use the top, you would make that curve. Why would squaring the top? No, squaring the linear. I don't know. Should still be a curve graph. That is true. I don't know. That's what he did. They came out with that. So who knows? So why would he? Wait. Whatever. We still got a long time to be. When is it? Yeah, we go last week. I got my U test tomorrow.
So here we go. There are. This one's going to be a little difficult for me to do with you guys, and that's okay. I'm going to be bouncing back and forth between this document and my screen up on the computer. As you guys perhaps could see, doing everything by hand is a little clunky. For some of you, takes a lot of time. And the line of best fit is really, or doing things with the line of best fit or the curve of best fit really is kind of your best guess on things. And at this stage, I mean, it takes a lot of practice to get a handle on what a best guess actually looks like. Some of you can pick that up quickly, and some of you, it'll take a little bit of time, and that's fine. Being able to use various pieces of technology to do this stuff for you, and I'm going to show you how to do a line of best fit on these things. The computer will do all the background calculations for you, because you can actually tell how good your line of best fit is by comparing it to all your data points. And I'm never going to ask you to do that, because that's a ton of it's a lot of extra busy work. But a computer can obviously do that for you very, very quickly. So there's 3 tools I want to show you. I'm going to go through graphing with Excel. Hands up if you have on your computer, if you have like not the online version of Excel, but like actually installed on your machine locally, Excel. Like you have access to Excel. Okay, cool, one of you. Hands up if you have, so I mean, this was great when the district had Google accounts for all of you, and then they decided to kill it. How many of you guys have a personal Gmail account? Fantastic. Then Sheets is Google Sheets is going to be your best bet for this stuff. And honestly, of the 3 things I'm going to show you, Google Sheets is among the best. Excel works okay. The online version of Excel kind of sucks. The one that the district has access to for you guys is pretty terrible. For one very key reason. Sheets is great if you have your personal Gmail account. See if you can get onto Sheets right now. And then there's a third tool I'm going to show you called Desmos. Hands up if you've ever used or heard of Desmos. Okay, hands up only if you've actually used it. Okay, cool. Some of you heard of it, some of you used it. Okay. So I'm going to jump over to, shoot, I shouldn't have changed that. I'm going to show you what it looks like to do some graphing in your compute. Oh no. What's going on here? No. Aha. I can fix this. Dang it. You're going to go back over here. You're going to go here. Bear with me, guys. I'm sorry. You're going to go there. You're going to go back there. Okay, cool. Now I've got 3 displays. I'm going to go like this. Aha, yes. I'm going to duplicate 1 and 3. No, that was the wrong one. Dang it. What is going on? Why is this so stupid? Display settings. Identify. Oh, that's 2. Okay, cool. I want to duplicate 1 and 2. Haha! I got it. Okay, so what I want to show you guys is how to use these 3 different tools, and I'm actually going to turn on display capturing on my video so you guys can see. Oh, wrong one. Nope, where is it? Remove you, yes, remove that. Yeah, go for it. Yes. Okay, cool. So now I'm recording. So now you can actually go back and watch the video and see what I'm doing here. I'm going to show you Excel first. So I'm going to boot up Excel. If you have access to an installed hard to your computer version of Excel, that's great. If you're forced to use one of the school's ones, the things you're going to see are going to end up looking a little bit different. But here's Excel. If you're not familiar with Excel, Excel is a wildly powerful tool. I've been working with Excel for, how old am I? 37. I've been working with Excel for something like 27 years since I was in elementary school, and I'm still learning things about it. It's a ridiculous program, a good ridiculous. So I've got some on the very, very back page of your notepad. I've got some 2 data tables that I'm going to work with here, just to show you, just some data provided for you, so you know where I'm working with. So I'm going to create a table here. I'm going to show you how to graph with it. So this is time in seconds, and I'm going to graph velocity in meters per second. And the way these things work is when you're graphing, when you want your computer to graph something for you, you typically have to put it into a table, X first, then Y. That's what it's going to assume. And so then it knows how to actually go ahead and plot these things. So if I want to do X then Y, time is always, 98% of the time is independent. So this one's going to look like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then this data is going to go 0, 10, 20, 29, 39, 49, 59, 69, 79, 89. Oh, nope. That should have been, did I screw one up here? 10, 20, 29, 39, 49, 59, 69, 79. That should have been, oh, I have 2 9s in there. 88. This one should have been 10. Ugh. Come on. 10, that one should have been gone. And 98. Okay, so there's my data. To take my table and actually turn it into a graph, you need to highlight your table, including your titles. Now, there's a few different kinds of graphs it's going to give you. I want you to do it the same way every time. You're going to insert. We're going to go to recommended charts. It's going to open a little box here. And there's a few options it gives you. I'm going to go over to all charts. and I'm going to put XY scatter. The XY scatter, what that's going to do is it's going to, rather than actually drawing a line through everything, it's going to give me just the data points. And then you can go back later and add the line you want to add. I'll show you how to do that. So I'm going to click XY scatter here. Now there's two to choose from. This one is actually, so if you take a look at what's happening here, this one's graphing time and velocity independent of each other. That's not the one we want. We want the one that draws them in relation to each other. We want one set of data for these two columns here. And so we're going to pick that guy. We click OK. And now I've got a graph to start playing with. And if we look at the data here, we can see it goes 0, 2, 4, 6, 8, 10, 12. This one goes up 0 to 120. So you can kind of get the idea that it's using the data that I fed it to give the scales here on the side. To make this graph usable, what we're going to do is we're going to click on the chart. We're going to click up here on the plus sign, and it says chart elements. So there's a bunch of things that the thing will either produce for you or not. We want to turn on the axes. We want to turn on the axes titles. So we can actually label these things. Okay, well, this one's actually, and in fact here, no, never mind, I lied, don't do that. We can go label these. This one would be velocity. In meters per second. This guy down here is going to be time in seconds. This guy here we want axes titles we have. Chart title we're going to manipulate. Grid lines are turned on. And if you click on the little arrow next to it, there's some options here. These are the major horizontal and major vertical. What we can do here is we can actually turn on some extra ones to give us more of a grid to work with. If we turn on the minor ones as well, it actually starts to give us lines in between. And then down here at the bottom, it gives you something called trend line. The trend line option, yes, sir. Yeah, like here. Okay, so then you highlight the whole thing, and then you go Insert, Recommended Charts, and you pick the XY scatter plot that only has one line. So you get your graph. We can change the title. This will just be velocity versus time. Oops, wrong one. The plus sign there. With the, where did I have it? With the grid lines, if I go to more options with the grid lines, you can actually start telling it where you want the grid lines to be. But I'll show you that later. So we'll get rid of you. The really important thing I want to show you is the trend line. So if I go down here and I turn on the trend line, it's actually going to give you what it thinks the line of best fit is. So I selected that option as well, and now I'm going to go away from it. We're going to go back here. I'm going to go trend line. I'm going to click on the arrow for more options. And if you open that window, what it's going to show you on the side here is it's going to give you a bunch of options for what do you think the trend line should be, and you can start to play with this. This is what a linear trend line would look like. This is what, oh, no, it doesn't like that. Come back here. Let's go to more options again for trend line. Where did it go? There we go. It doesn't actually like it if you pick other ones. I do polynomial. I could do polynomial of order 2. When it asks you for the order on your polynomial, you're just asking what value do you think Like, is it a squared? Is it a cubed? Like, what could you think it would be? Or if you wanted a power one, that's not even an option. Exponential is not even an option. So this data here is going to be linear. And then in the trend line options, what we can do is we can go down here at the bottom and say, if you can see this option, it says display the equation on the chart. So the computer generated a line of best fit. We click on that option and we can say, okay, here, look, this is the equation. Where are you here? I want to grab, come on. There we go. I want to grab this guy. I want to make it bigger. This is the equation for this data. You can see here, so this is the slope. It calculated it for us. Y equals mx plus b. And there's the y-intercept of the trend line. Even though 0, 0 was a point, 0, 0 is not the y-intercept of the line of best fit. So that's the equation that we would then work with. So the computer will generate all that for you rather than you having to go back and doing all this work. If we want, where's the option here? Where's the trend line? There is a way, so you can look, the trend line starts at our first data point. It goes to our last data point. You can actually, using Excel, forecast it. You can extend it forward. If there's data you want that's beyond the data set provided, we can extend it. I don't know, maybe we want to go 5 more. So our data ends here, but using the trend line forecast option, we can actually force Excel to extend our line of best fit. Maybe we wanted to see some data way over here. So now we've got a fantastic little graph done in Excel for that data provided. Hands up if, well, actually maybe don't do that. I'll give you a couple more seconds to look at it, and then I'm actually going to move over to Sheets. So those of you with a Google background can work with this as well. Are there any questions about what I've done with Excel? Okay, I am recording. I'm recording my screen here, so you'll be able to go back and watch the video if you need to. Yeah, Emma? Yeah, I can show the trend line again. So in Excel, the trend line was you just click on the graph in an empty space so that it brings up this plus. You click the plus, and right at the bottom, you go to trend line. Are you in the online version? You're not in the online version? It doesn't have that?
Oh my god. Like, get rid of more, bro. I just want to. Yeah, I probably look fun. It only gave me 4 megabytes back after the legal. I'm going to show you guys some. God, what is this guy been doing? Get rid of it. Get rid of more. They still have storage. Bro, it didn't even form like the. I don't even know if I want to clean up space. You guys let me help you out here. No. Unsupported videos. It's 900 kilobytes. Okay, get rid of something big. Large storage. I don't want to clean up the service. Okay. Which one? Yo, why you get email from that? You definitely put an email on the site, bro. Let's find it. You can come on, make a comment. It's actually crazy. Why? Wait, we should check yours. Spamming? I don't know. Yeah. I think that was my update. Oh. I don't know so much. Okay. Need 1 second.
Okay, if you're on a Mac, we're gonna go trend line for Excel on Mac. Okay, here we go. So that's Dana. You want to go design?
I don't know why that was. Yeah, dude, when I pulled up, I read like, ooh, yeah, I wanted to read the other one.
So this is where you got it.
Yeah.
It looks like a straight line.
Yeah,
There it is. And now you can click on it. This is what opened up this. This is where we can set display. So that's how you would do that. So add chart element to the top. Okay. So there it is. That's Mac. And well, that's Excel on anything. The next one is going to look like this. So here's Sheets. If you're using Google Sheets, let's open up Google Sheets. If it lets you, oh, come on. I'm signed in already. Why are you giving me grief? Here's Sheets. I'm going to create a blank spreadsheet. I'm going to use the second data set. Oh, actually, I'll use the same data set for this one so you can see how it looks. So we're time in seconds. Actually, you know what? This makes my life so much easier. I'm just going to go here. I'm going to copy this table straight out. And I'm going to go over to here. Boom. Okay, so I've got my data. Here we are in Sheets. Here's how you do the exact same set. And again, you have the instructions. I'm just demonstrating how it plays out. So, graphing with Sheets. We're highlighting the table, including the titles that I gave you. You're going to click Insert, just like we did in Excel. We're going to go down to Chart. Boom. It'll take a little bit, and it'll open that thing up. Now, it will create for you a chart before you tell it what kind of chart to draw. So we're going to open this thing up. We're going to edit the chart. And now we're going to change the chart type. Now that it's already given us one, I don't like this one. We want to go and we want to say, okay, it's giving us selected options. I'm going to scroll down and I'm going to pick scatter. The thing that I like about Sheets is it's a lot more intuitive. You can see here, like in Excel, where I actually had to go change the title myself, and I had to go change the axes myself. As soon as I picked a chart, Sheets interpreted what I wanted it to do. It picked my axes titles, and it labeled them for me. That's time, that's velocity, and it gave me a title for my graph, velocity versus time. Sheets is way more intuitive than Excel is. Excel is more powerful. Sheets is way more user-friendly. And for what you guys are going to do, user-friendly is better. So Sheets, I can't pump up Sheets enough. There's our scatter. Now we're going to go customize. Boom, we're going to go over here. There's a ton of ways you can customize this thing. If I go chart axes and titles, you can see it's done for us. And then every drop-down menu has a different set of things. Chart title, I can change my horizontal axis title. I can change my vertical axis title. But again, it's done it for me already. I don't need to change it unless I want to. I'm going to go down here to horizontal axis. I'm going to change some stuff in here. The horizontal axis is my time axis. You can change the min value and the max value. So on this one, having a min 0 and a max of 10 is good. I don't need to change those. You can change the scale if you want, though. Changing. Oh, that's not where I want it. Never mind. We'll change that in a second. So I get rid of the horizontal axis. Vertical axis, same deal. You can force a max value and a min value if you wanted to. If you wanted to extend the graph, you could change these values. I'm happy with what I've got, so I'm going to leave it like that. And then I'm going to go down here to grid lines and ticks. I'm going to stay on the vertical axis for a second here. I like to add the minor grid lines, and you can see what it does. Minor grid lines starts to add all these horizontals. I'm also going to add the major ticks and the minor ticks. Do I want to do that? Hold on. Yeah, I want to do that. Maybe I don't want those. Yeah, I do want those. Shoot. There we go. Oops. Edit the chart, customize. Here we go. Grid lines. There is a way where, oh, here. So for the vertical ones, the major spacing and the minor spacing, this one goes up by 3s for some reason. That's weird. So you can actually go and force it to change. The major spacing, maybe I want the major step to be 5. So now this one's going to go up 5, 10, 15, 20, all the way up to 100 instead of going up by 25s. Maybe you want it to go up by 10, so it doesn't look quite so cluttered. That's what a 10s would look like. What's this? If I go minor spacing type? Oh, yeah. So then my minor spacing, I want there to be 5 ticks every 10. So it's going to be 2, 4s. Actually, I want 4 is what I want. So now by selecting 4, I've got 1, 2, 3, 4, 5 steps every 10. So that means every one of these is going to be valued at 2. 2, 4, 6, 8, 10. So I've got something that looks like that. And I can go and I can change my horizontal axis as well. I want the minor grid lines. I want the major ticks. I want the minor ticks. And I'm going to go ahead and change my step count as well there too. I want every step to go up by 1 maybe. And then I want a minor tick in between there. So what that's done here is that every one of these big jumps, every one of these big jumps is 1. So every one of those is the 1 tick in between is half of 1, so 0.5. You can crank that up if you want to. If you want 3 ticks in there, now everyone's a quarter. Maybe you want something that looks like that. It's up to you to give yourself meaningful values for those. We've selected all of those options, and so now what I'm going to do, let me get rid of you for there for a second. I'm going to go back to this. I'm going to click on these 3 dots. I'm going to go back to edit. I'm going to go back to customize. And there's an option here for series. Now, it's not obvious what series is, but it's where we want to go. So I'm going to click on series. Oh, sorry, click on series. And all the way down in series, this is where your trend line option is. So I'm going to open up my trend line. It's going to put it on the graph, and it's going to give us a whole bunch of trend line options now. Within the trend line options, it should give us, where is it? Right here. There's an option to choose which kind of graph we think looks best. So there's linear, exponential, polynomial, logarithmic. And again, some of you may not have seen these graphs in math before, and that's fine. I'm going to give you guys an assignment here. Actually, we'll start it tomorrow because we only have 10 minutes left in the block. We'll start it tomorrow, where you actually will be able to, you're going to get a graph that's not linear. It's going to be curved. And so you're going to have to play with these options to see which one is going to actually fit it the best. So linear is the one that I want. We're going to go down here. And the label, I want to use the equation. So it puts it up here at the top. It says my equation is velocity, the y variable, is equal to 9.81x plus 0.0455. If I want to make this thing bigger, I can go font size, I can go 14, I go 20, make it very readable. And if you go back and take a look here, on the other one, Excel gave me 9.8091. That will round to the same thing. And the y-intercept was actually the same on both. So Sheets and Excel are doing the exact same background calculations. It's giving me the same value for my y-axis. Where did I lose you, Kale?
I have it all labeled out,
You know something different than I got? So this is Sheets. I'll give you a second to play with Sheets. Comments, questions, concerns about Sheets? Would anyone like me to give you a little more time to sit here, or can I show you Desmos? Okay, so here we go. Desmos. Every one of you with a computer, I want you to navigate to this website, desmos.com/calculator. Desmos is a fantastic little program. But it has some advantages, it has some disadvantages. You'll see them in a second here. So once you get to this site, if you've never used Desmos before, Desmos is insanely powerful for what it is. If you have a future if you see yourself going into university sciences, I would encourage, it's a free account. I would encourage you to create a Desmos account. Not right now, because I want you can use it without an account, but with an account, you can actually save your stuff. Like I've got programs here that I've built in Desmos. Some of these are examples. I got some that are saved. I can jump back and forth between stuff that I've worked with before. So creating a free account in Desmos, certainly not a bad idea. So here's how this same procedure would work in Desmos. Desmos, you can start typing whatever you want into this thing. To put a table into Desmos, you ought to click the plus and then it asks what you want. Are you going to make an expression, a note, a table, a folder, an image? So we're going to add a table, and now we can start changing these things. My x variable is going to be time in seconds. My y variable is going to be velocity in meters per second. Oops. What's this? Too many variables. Okay. We're just going to call that t. And we're going to call that guy v. So I went to the plus, and I went add table. So this Desmos is a raw calculator. It didn't like it when I put in too many variables, so I had to reduce it. Instead of time and velocity, I'm just putting t and v. And time should be little t. So then my data is going to look like this. I'm going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It's intuitive. It started plugging things in there for me. My velocity is going to be 0, 10, 20, 29. And you can see it's starting to plot the points on my screen. 39, 49, 59, 69, 79, 88, and 98. So there's my data in Desmos. Now, there's lots of it I can't see. To play with the graph and make it look like what I want it to look like, I go to graph settings here, the little wrench in the top right corner. And I can say, okay, well, I want to set my x-axis and y-axis to be particular values. You can move the graph around just by clicking on it and moving it around. So I'm going to set it so it looks like this. I'm going to leave the negative values as they are. And I'm going to go ahead and I'm going to change my y value. Sorry, not the y value. I'm changing the top value for x and y. X, I'm going to go a little bit beyond my data. So if it said 10, I'm going to go to 12. The y, the data goes up to 98, so I'm going to say 105. And so now what it's done there is it set itself so that my data is presented on the screen. And now if I want to zoom out from there or in, now it's still going to use that same shape. Yes, Emma. Yes, I can slow down. I just have 6 minutes left. I want to make sure I get it all in. Where do you want me to go back to?
Where you click here and then you have to do this.
Yeah, okay, so like what I've got on the screen? Okay, so I clicked on the wrench. I went down to x-axis and y-axis, and I just changed the top x value here and the top y value here so that it encompassed all my data. So you have to play with whatever those values. I picked 134 gives me space up top, and 17 gives me space off to the side, and it's going to encompass all my data. And you can pick steps if you want. Maybe I want my steps to be 0.5. Actually, I don't want steps. I don't want that. I want steps of 1. I like steps of 1 there, and I'm going to go steps of 5 there. Now let's go 10. There, steps of 10. I can put labels on this too. My x-axis is time in seconds. My y-axis label is going to be velocity in meters second. And so now I'm starting to get something that looks an awful lot like what I created in Sheets and Excel. This one I don't have written instructions for. Marcos, do you know how to use Desmos? Okay, then you're good. So now what I'm going to do, no, I don't want that. We're going to leave that alone. Okay, we're going to close you. Now with this guy, I'm going to click on my data. Shoot, where did it go? There we go. So on this thing, what did I do? How did that just show up? Delete the regression. Okay, so I've got my data, and I've got, if you look at the table, there's now an option on the table that didn't exist before. It's these 4 dots here with a line, and it says add regression. Now, Desmos's version, where it says add regression, that's the same thing that Excel and Sheets did when I said add trend line. So we're going to add the regression here. We can select a bunch of different options, but again, linear, the data looks like a straight line. Let's call this a linear regression, and it immediately spits out the equation for us. There it is right there. No, I want to forget that. The one thing it's not going to do is put the regression right on the equation for us. That's fine, or on the graph for us. That's fine, but it gives you the equation right down there in the bottom corner. Then there's some statistics down there. That's fine. Don't worry about them until you can take a stats course. Those aren't going to mean anything for you. But now effectively what we've done in Desmos is the same thing I had you do in Sheets and Sheets and Excel. Desmos is even more friendly than Google Sheets, but it has less options, and it's a bugger to print. But we're done. I can save this thing. I can give it a title. This is data sample 1. I can save this because I have an account. And I'm done. So guys, I know you're packing. Hold on. I still got 2 minutes. I've shown you 3. I do not care what tool you use going forward. I want you to pick one of the 3 options and get comfortable with it. And then moving forward tomorrow, so your test, I've made a decision now. Your test isn't going to be till tomorrow. It'll be Thursday next week. It'll be Thursday next week. Hands up if you're done the review already. Or any of you finished the review? One of you, cool. So here's how the next couple days are going to go. I am going to give you our first lab tomorrow. Tomorrow's lab is all tech-based. I'm going to give you four data sets, and you're going to make digital graphs for all of them. So that's going to be tomorrow, no school Friday, no school Monday, and Tuesday. Wednesday is going to be your last day to work on the review, take up any questions with me that you may have, and then Thursday is going to be your chapter test for this stuff. Have a great day. We'll play with this more tomorrow. If you grabbed a computer from the lab, I want you to put them all on this pile, right on the corner of this table up here. And I will deal with them. If you grabbed a computer from the lab, one of the school computers, bring it back here. Good to see you guys. I'll see you again tomorrow. I hope.
What if we have a graphic marker?
And the French curves. Yes, I want the French curves. In the blue box up at the front, please. Thank you. The French curves up here next to my ruler. There are ways to do this in the graphic calculator. I don't know what they are, and there's so many different kinds of graphic calculator. And I want you to print these things. You're going to have to print them out and submit them to me. And because of that, you can't. I want you to use computers.
I didn't get your
You didn't get to review. I'll give it to you tomorrow.
I'm not going to be here tomorrow.
Okay, I'll give it to you right now. Sorry, Kai. I think my TOC put the reviews over here for some reason. Yeah, here you go. You're welcome. In the bin. You guys are B. Oh, okay. Who's gonna be back? Yes.
Do you have like extra wrapping paper?